Hello friends, welcome back to my YouTube channel. It's Vian. I know I haven't done much videos lately. I've been busy with college, but today I'm gonna make it up for you because I'm gonna solve 3 different problems, exam problems actually, for these 2 methods and this type, which is frames and trusses. So get your paper and pen and your calculator ready because I'm gonna ask you some questions. You'll have to solve several things by your own and we're gonna do it together. So let's get started. First example is gonna be about portal method. As you can see, we have this multi-story building with lateral loads, or you can say wind loads. It requires for me to find the moment diagram for column AC and AD. Since our work is going to be only on this story, so we're going to take it on the side and work on it. And insert internal hinges in the middle of each beam and each column, as you can see. So 3.2 going to be divided by 2, which is going to be 1.6. Here's the lateral load that we have only on that story. So for each column that we divided or took apart from the original building, it's going to contain on the side, it's going to be 1V and 1V, and in the middle it's going to be 2V. How can we determine the magnitudes of these two? It's very simple. It's here, 4V, because 1, 2, 3, 4. 4V equals to 15 different directions, so each one V is going to be 3.75. So 3.75, 3.75, and this is 2V, 7.5. I'm going to take each part on its self and solve it, so pay attention because it's going to be kind of easy, but you have to pay attention to it. So this part, I took it here. Here is the lateral load and here's V that I determined. How can I determine these two? I'll name this joint as P and this joint as L. Summation Fx, I found this one, and summation moment about P to find this force. I'll transfer these two forces, which they are here for this part, to this one. The same magnitude but different direction. As you can see here, same magnitudes but different directions. How can I determine this one? Summation Fx. How can I determine this one? Summation moment about this joint. I can find this one. And summation Fy, I can find finally this one because I already have these three. This one, and this one. These two forces, I transfer them here. Originally they're here. So same magnitude, different direction. Next, I'm gonna use these forces to find the moment diagram for each of the sections. So for this section, which is this one, I have these forces that I found. I'll take this part and do a little work on it here. I did a section here and I assumed that moment on the left is going to be compression, so every positive magnitude for moment I'm going to draw it on that side because that's how I assumed it. That's how you should always assume it as well. So the moment equation is going to be 7.5 times x. This is the distance. So if x is 1.6, here is 1.6, this is the distance, it's going to be 12. 12 is positive, so I'm going to draw it. For this side it's positive, and the other side it's going to be this one compression, this one compression as well. Here it's going to be 0 because it's an internal hinge. For AD, the same procedure. Here is the moment equation and x is 1.6, it's going to be 6 positive on that side. So here is the moment diagram for AD. That's portal method. It's very easy. It's all the same for every type of portal method. Now it's gonna be the cantilever method. I have a multi-story building again. It requires for me to find moment diagram for I, J, K, L. So first I'm gonna find x dash, which is the moment of inertia or the centroid of this multi-story building. For every section I have its area. So the equation says summation xi times ai divided by summation ai. So I'll take an original point to calculate x from it. Is going to be this one. You can choose any, but this one is easier. You can find it easily. So the distance from this one is 0, so I'm not gonna take this area, and then the distance is going to be 4 times this area. As you can see, it's here, 4 times the area, and 9 for this one times this area, and then 12 times this area, divided by summation of all the areas. Here is it, and it's going to be 6.2. That means from here until there, it's going to be the centroid. Here's the centroid, and 6.2 minus this distance is going to be 2.2, and the same for these two. So I'll use the stress, which is P over A, to find these loads and these as well. So since the building is going to be moving this side, so this here is going to face tension stress, and here it's going to have compression because it's going to push this one, push it down, so it's going to be compression, and this is tension. I'll name these joints as M. As you can see, it's here M, MX has MX and MY, and N for this one, and O and P. This is just to make it easier for me to solve. It doesn't matter how you name them. So here I have MX and MY, X and Y direction. So now let's start making some relationship between the equations so we can solve them together. So I'll show you one example, and then you'll know how it's solved, and I'll put this thing in front of me so I can know how explain it, and so you can do it on your own from now on. So I'll say stress on M divided by triangle similarities, summation M over 6.2, which is this distance, equals to the stress in O divided by 2.8, which is the distance. We know that stress is equals to P over A, which is load on area. So stress on M is going to be My divided by the area. Here's the area. We still have this distance, and the same for the stress on O. So we get this relation. All these relationships make it in the term of My. It's going to be easier to solve, and you'll see how. The same goes with the N stress on N and stress on P. You can see it's divided by the area times the distance from the centroid. And here are the 3 equations I'm going to use. So I'm going to take summation moment about neutral axis. It's going to be minus 20 times 2. Here's 20. We can say it's here. Here's minus 20 times 2, which is the distance here, because it's 4 and we took the half of it, so it's going to be 2. And then plus 6.2, this is the distance for My, plus 0.237 My, which is this one, stress of O, times 2.2 here, for this one, it's gonna be OY, stress on O, and sorry, this one is for the N, stress on N, because we're gonna M and O and then P. So here's for O, and this one is for PY. As you can see, we have one equation and one unknown, so it's going to be easy to solve. We get my is equal to this number. All of them are in positive, so our assumption in here is correct about this being tension, then tension, and these two are compression. So you have to do the moment diagram for each one. How? You're going to use the same procedure for portal method. Here for each section, here these ones that I found, and here, these four, I already taught you how to determine it, so you can do it by your own and check these numbers. And then you have to draw the moment diagrams for these parts, because it's required from us to find the moment diagram for this girder. Comment below or send me a message about the moment diagram for this one, and I'll check it for you. That's pretty much everything for cantilever method. It's very easy. You can try it much more on Hibbler textbook. It has a lot of good practicing examples. Now we're going to shift to the third and last type for today. We have a frame, a regular frame with truss. It has a truss inside it, so it requires from us to find the force in each member of the truss. So the idea of this frame is very easy. You don't have to be confused about it. It's always the same procedure for every type, but there are some tricks that you have to learn by your own, and I'll teach you through it as we solve together. So I have this regular frame. These are fixed. It will tell me in the question already. So how do I start solving? Okay, from this lateral load till the support, it's going to be H. For example, if I didn't have this lateral load, from this force until the end, until this fixed load, fixed reaction, it's going to be H. So for this case, I have from here till here, it's going to be H. So I have to insert an internal hinge at H/2. So all of this is going to be 6 meters. 6/2 is 3. So this one and this one is our internal hinge that I inserted. I will cut this part of the frame and truss and take it in here, because I'm going to solve this one. As we can see, if I cut an internal hinge, we have normal and shear. We don't have a moment. Moment is 0 there. So that's going to be a privilege for us. It's going to help us to solve. How I'm going to do that? I have 1V here because it's on these sides. If, for example, but it's not going to happen. For example, if I had another column in here, it's going to be 2V. But for this case, it's never going to happen. It's very rare. So I say here's V and here's V. Summation of X I'm going to take for this frame that I cut. It's going to be summation of X plus 6 plus 12 minus 2V. It's going to each V is going to be 9. 1V is a 9. So here it is. I wrote them down. Why it's on that side? Because these two lateral loads, these two wind loads are on that side. So as a reaction to keep it in equilibrium balance. And then for the normal, this is you have to pay attention to it. Just as we did in cantilever method, we knew that side is tension and that side is compression. You see these two lateral loads, it's going to push the whole structure on that side. So this is going to be compression as the nature of the structure to prevent it from movement. It's going to be compression to push it so it wouldn't move it, and this one is going to be in tension. How can I find these? Well, it's going to be by summation moment about h. I named this hinge as h and this one as h. So summation moment about h is going to be minus 6 times 6, the distance, because here we have 3, see? And here that I cut it, it's going to be 3. Minus 12 times 3 plus n2 times 8, which is the distance. So n2 is going to be 9, which is equals to n1, but they're in different directions. So if you take the summation fy and summation fx, it's going to be 0. That's how you know it's in equilibrium and you solved correctly. Then we're gonna start finding the forces in each truss. I'm gonna make only one sample, but then you have to find the other forces in the rest of the truss members, and you're gonna give it to me on the comment below and I'll check it for you if it's correct or not, just to practice. So I took this part, I'll show you on the original. It's this part. Is this part, okay, with this one of course, because I got rid of this to help us solve. So here is C, here is G, and here is H. So summation moment about D, this joint, here is D. To find this force in the truss, which is a GF, it's going to be 3 kilonewtons in compression. That's all I have for you guys. It's I know it's a lot, but it's not that difficult. You can solve it, you can do it. Comment below if you have any more questions, if you have more requirements, because the exam is very close and it's you have a high chance to get a very high mark. It's easy. Thank you very much, and solve it. You don't have to take a lot of time, it's just easy. Thank you very much again, and goodbye. Good luck with your exam as well.